So like a zombie in the movies, it can create more zombies. To tie that back into the yellow leaves beget more yellow leaves because they attract pests. They create a microenvironment on the plant that's conducive to causing more stress to nearby leaves. That's again why you prune them off. And when you prune a yellow leaf off, it does a couple things. One, that yellow leaf was using nutrition that would have been better invested somewhere else. Two, it's causing, again, like attracting pests and causing dysfunction in at least the local, if not the whole plant. And by pruning it off, now more nutrition can go where it's well used and you've made room for new growth.
All right. Well, it's a real pleasure to have Gregory Kelly on the show today. Welcome.
Thanks for having me today. I'm looking forward to an in-depth dive into longevity and senescent cells.
Yes, this is Senescent Cells, Senolytics. We are going to cover this part. We're going to explain exactly what this is and why we need to know these words. These are big words or maybe words that people haven't even heard yet. So why don't we explain a little bit what is cellular senescence and then try to keep in mind maybe what a woman going in peri or postmenopause really needs to know. Why should she care about this?
Yeah, so cellular senescent cell is embedded in it. So let's just start with cells, right? They're the building block of life. And in a simple sense, our tissues are only as healthy as the cells in them, and we're only as healthy as our tissues and organs. So I think some of my mentors when I went through naturopathic school would have, even back then, been all about like, let's promote health in tissues at a cellular level. And so cellular senescence isn't a somewhat old term. It's been around for many decades, and it's considered a hallmark of aging. And for the listeners, there's 12 hallmarks of aging, but just think of those as characteristics, that they're things, whether scientists are looking at mice or monkeys or us, that aging has in common throughout all organisms. And one of those is senescent cells or cellular senescent. And the best way, I think, to think of senescent cells is they're just a type of really stressed cell. And they become so stressed that the body can't repair them anymore. And so because of that, ultimately the goal, and this is what often happens in young people, is that the body will remove those stress cells. And so that kind of makes room for new growth. As we get older, those processes don't work so well. So these senescent cells accumulate, and hence there being this idea of cellular senescence as a hallmark of aging. And the analogy that I've used, and in part this is because at Qualia, our head of marketing is an avid gardener. And I was trying to figure out some way to make this make sense for her. And so I said this, all right, like imagine today you walk out into your garden, every plant, leaves are all green, healthy. You're like, I'm a great gardener. And now next weekend you walk out and one of the plants has a few yellowing leaves and you think, oh, this isn't good. Like what's going on? And yellowing leaves in a plant are a sign of stress, right? It could be too much sun, too much water, too little water, lack of nutrition, a pest, you name it. But it would be a plant stress that causes that. And now you go out a third weekend and there's even more yellow leaves and that plant's really struggling. So what a good gardener will do is one, try to figure out what's going on to cause that, but then we'll prune those away. And in a sense, senescent cells are like those yellowing leaves that as we get older, we all become that plant that has more and more yellow leaves. And senolytics, which we'll talk a bit, are a little bit like the gardener coming out to try to prune them away.
Mm. But as I understand, we call senescent cells zombie cells sometimes. And it's because they cause some damage or they wreak havoc or they bother the other ones in a way. Whereas I'm thinking yellow leaves, I mean, maybe I'm not a gardener. Maybe is it the same thing or we need to take it next level?
So first we'll go to the zombie and then we'll tie that into the yellow leaves. So there's two reasons senescent cells are often referred to as zombie cells. The first is because think of like a cell, it should like a live, healthy cell can make offspring of itself, basically like daughter cells, son cells. Then you also have cell death at the other extreme, and cell death just means a cell breaks apart into little pieces. And then the immune system comes in and gobbles them up and recycles it. So a senescent cell in the aging sense is somewhere between. One of the characteristics of senescent cells is they can't make offspring. So they're not fully alive in that sense. And they haven't gone through cell death. So they're still hanging out in the body. So they're stuck in this in-between spot. So that's part of the reason for the zombie cells. They're in between live and dead. And the other reason is senescent cells secrete all kinds of compounds into the microenvironment around them. And those compounds tend to be really inflammatory in nature. And so what they can do is they can stress out nearby cells. And actually, new science has even shown they can stress out remote cells, so cells really far away from them in the body, and cause them to become senescent, right? So like a zombie in the movies, it can create more zombies. And to tie that back into the yellow leaves beget more yellow leaves because they attract pests. They create a microenvironment on the plant that's conducive to causing more stress to nearby leaves. So kind of the same, right? That's, again, why you prune them off. And when you prune a yellow leaf off, it does a couple things. One, that yellow leaf was using nutrition that would have been better invested somewhere else, right? Two, it's causing, again, like attracting pests and causing dysfunction in at least the local, if not the whole plant. And by pruning it off, now more nutrition can go where it's well used and you've made room for new growth. And that's kind of the same thing. If we can get these zombie cells or senescent cells to finally go through cell death, break up into little pieces, then it creates an opportunity for nutrition to go to the healthy cells and for new growth. And the new growth is something we always want.
Oh, that makes perfect sense. Thank you for clarifying that. And so then as we age, we accumulate more senescent cells, I imagine. When you're younger, probably don't have that many. And if they are, maybe they're outnumbered. So what's happening as we age?
Yeah, so I usually use the distinction transient and lingering to describe senescent cells. When we're young, like say you and I decided to do some crazy intense exercise, we would make some senescent cells because of the trauma. And 20, 25-year-old Greg would have really quickly, within days to 2 weeks, removed most of those. Either they'd have gone through cell death or the immune system would have come in and found the stragglers. I'm 62. Right now, I'll be 63, not too far in the future. This version of Greg at this age will make more scientifically. That some of the scientists, when they've looked at this, they would use words like an explosion of senescent cells after intense exercise in older animals is what they've looked at. And then weeks later, they're still lingering. They haven't gone through cell death. And that's the key thing. The senescent cells or zombie cells we talk about in an aging contest don't go through that cellular death process. They've figured out a way to resist it.
Mm-hmm.
So the senescent cells in an older person are qualitatively different than the ones a young person would make.
So you said an explosion of senescent cells. So the way I first understood it is that a younger person makes senescent cells when there's a stress or trauma in the body, but it's cleaned up very quickly. And so that thought then said, as we age, then we clean it up more slowly. But the explosion word made me think that, are we making even more with the same exercise or same trauma? We're actually creating more senescent cells and then taking longer to clean them up.
Yeah, so we make more, and then many of them escape going through cellular death. Like that's the characteristic of senescent cells in aging, is that they resist that cellular death process. So there's a few different things going on. We make more for the same stress. Some of that might be our genes, some other damage. They hang out a lot longer, and fundamentally forever is what it looks like. And then our immune system should always be the backup plan to remove any type of stress cell. And as we get older, our immune system also becomes senescent. It becomes, it's called immunosenescence, right? Like old, it's not as functional. So the bottom line is when they've looked, and the only way to do senescent cell research is to do tissue biopsies in animals. There's no really marker in the blood you could look at. But what they find is in all tissues, they just accumulate more and more rapidly as animals get older. And then they contribute to many of the things that we think of as problems with aging, whether that's, skin health or joint issues or brain struggling with memory, on and on.
So then it makes sense to, just think as we age, then we have to deal with this more, and then the nutrients can't go to where, if you want to have the tree and the leaves analogy, well then, if we're not able to clean this up, and then do you see that people with more senescent cells and less cleanup are actually look older, or they have more disease, or they are sort of aging faster in one way or another?
So most of the work on that's all been done in animals. And so senescent cells, like I said, have been known about for many years. that they secrete these, inflammatory compounds. That was identified by a female researcher at Buck Institute of Aging back about 18 years ago. But around 2010, they did an experiment. They modified genes in these, I think it was mice, but it was a rodent model. And what they found is if they could program them to remove senescent cells as they got older, then their fur was more glossy. They stayed leaner. They lived longer. And so that was a turning point in the field of cellular senescence because all of a sudden it was like, oh, these, it's not just an inevitable thing. If they could be managed better, then we could age better. And in 2015, Mayo Clinic scientists and scientists at the Scripps Institute of Aging teamed up and published a paper that used a word that they coined called senolytic. And a senolytic, as they defined it, was something that would finally make these lingering senescent cells go through that cellular death process. And what they found in or reported in that study was that also allowed these animals to age in a healthier way. So since then, really, I think often this happens in science. When there's something you can do, the research explodes in that. So since 2015, there's just been a huge amount of studies on both senescent cells contributing to issues with aging and senolytics that manage that burden, helping to manage those issues. So it writ large, like ovarian aging would be a classic thing that's been investigated.
Oh, yeah. I think we need to give that a bit. I'm wondering, though, you mentioned this mice model that they program the mice to have to clean up their own senescent cells. How did they do that? I mean, how did you program a mouse to do it? It sounds like a computer program.
Yeah, I mean, it's a transgene. It would be the word, but just think of it this isn't an accurate representation, but it would be directionally correct. They genetically modified them so that their immune system would find and remove any cells that had particular markers on them that would identify them as senescent cells. So that they just became much better at removing that type of stress cell.
I wonder if there were any side effects of that. Like there's a payoff, there's a trade-off for getting one and then the other because you're messing around with the genes. And that's probably more science that needs to be done on that.
Yeah, I think your sense is correct. Most things in life have a trade-off. So yeah, I think it's always good to think about that.
So then I'm wondering, the woman who's going through this menopause transition, we've done there's some research that's been done on, let's say, glycans and in biological age. And they see as a woman is going through this transition and she loses all her hormones, or not just that, mostly the sex hormones right now, she's actually aging at a much faster rate without those hormones. So I'm wondering if there's any correlation, does she create a lot more senescent cells because of this short period, let's say not short, it could be a couple of years, it could be 10 years, it could be more, right?
Yeah, so there wouldn't be a clear answer in humans, in part because senescent cells are really hard to measure. A scientist needs to really check several different things to say, okay, this is a senescent cell, and they have to get the senescent cells from tissue. And really, if you were things don't always happen evenly in the body. Like if we exercise, as an example, there's adaptations that happen in muscle that may not happen in some other tissue. And so most of the knowledge has come from animal studies so far. And what would definitely be true is women that are aging, or animal models as they age, make more, and that accelerates, almost like a snowball rolling downhill. But whether menopause, is the tipping point or not, it's hard to say. But there's something, so senescence can be caused by lots of things, right? Lots of things can stress cells, mitochondrial dysfunction, nutrient inadequacy, UV radiation, if it's too much for our skin cells, as an example. So many of the things that can stress us can stress cells. And so think of senescent cells as a category of stress cells, but many things might have made a particular tissue or cell senescent. And one of the newer things discovered that makes cell senescence is called therapy-induced senescence. And what that means is some of the therapies used to treat cancer are intended to cause cellular stress. And the idea is the stress is so big, it will cause cancer cells to finally go through cell death, right? So we want that. But because it's a big stress, it inadvertently causes some healthy cells to also become stressed. So therapy-induced senescence means what it sounds like, right? We went through a therapy that did something important, but as a side effect, we made more senescent cells than we otherwise should have at that point in our life. And so that has been looked at both in animals and humans. What happens to, say, a woman after they go through chemo and radiation, maybe for breast cancer or some other cancer, and they're more susceptible at an early age to all kinds of age-related issues, right? So it's almost, in a sense, prematurely aged them as, and you had mentioned it, right? There's often a trade-off for things. So that's the trade-off for getting well. In that case, is that they've, depending on the therapy, likely contributed to making a lot more senescent cells at their age. Right. And so one of the things then you can see with oncology treatments is a woman would potentially go through menopause at an earlier age, right? It can trigger that. So just piecing things together, I think, like, my sense would be the answer is that yes, a woman would make a lot more during that transition, and those cells themselves might actually contribute to both causing that transition and making it more challenging to go through.
Yeah, I can imagine. So then I'm wondering, I just lost my train of thought. Then one question I was wondering if surgery causes a lot more senescent cells to occur, because you said exercise. I mean, that sounds like a good thing, but what about something pretty traumatic like a surgery?
Surgery, probably, like senescent cells in a young person, anytime there's a need for more healing, senescent cells, in a sense, their positive role would be they would call in reinforcements to heal that area. And as long as then they're removed quickly, then healing can happen. In an older person, when they linger, then they might be calling in things, but the healing doesn't happen as well. So an older person going through surgery usually won't bounce back as quickly as a younger person. If they have trauma to their skin or have a cut, it's often slower to heal. And some of that's the senescent cells that should have been doing something positive because they hung around, they're now interfering with that.
Yeah, so then I imagine it must be even harder to heal because your body's already trying to deal with the trauma from the surgery, and then it's got to deal with senescent cells, and it's like you said, just can't, it's hard probably to be in all places at once. So if there's one thing we can do, well, let's clean up the senescent cells. So, and you mentioned senolytics. So as being able to clean this up, and so what are senolytics and how does that work?
Yeah, so when the Mayo and Scripps scientists originally coined the term, what they meant by this was things that you would take orally, and that they would help this senescent cell that's lingering finally stop resisting going through cellular death. So they would basically change the vote, right? So at any point in time, just think of every cell in your body is voting, should today I stay around, or should, like, today be the day I finally go through cell death? And there's proteins inside cells that are the voters, so to speak. And a senescent cell, the voters are saying, yeah, we want to hang out even though we're not contributing to health. And so senolytics were things that, in the most fundamental level, changed the vote. And all you need to do is get the vote just a little bit in favor of we're going to finally go through cell death, and then the cell will finally go through that process. And so the first two compounds they identified as senolytics, one was a immunomodulator medication called dasatinib, and one was a polyphenol called quercetin that I'm sure some listeners have taken. Quercetin, I learned about quercetin when I went through naturopathic school back in the early to mid 90s. So, and what they found was that the two stacked together were more beneficial than either one on its own. So that combination, D and Q, is how it shows up a lot in research, is the most studied senolytic in science to date.
Okay. So by taking this either drug or this supplement, quercetin, then that's able to clean up some of the senescent cells. Do we know how much? Like 50%, 100%?
No, again, it's just really hard to, like, senescent cell research is somewhat in its infancy still, but then you would have to be counting cells by scientists that really know what they're looking at. But the sense would be, so the way they approached it was they called it hit and run dosing, or just think intermittent for listeners. So they would give the D and Q pairing just briefly, so for a couple of days usually, and then wait. And mice, rats live a lot shorter than us, but they would usually wait 7 to 10 days. And then they would do another cycle. And then what they saw in that original study was similar to the transgene experiment I mentioned earlier. The animal's fur became more glossy, they became leaner. All these characteristics of a younger animal they expressed. And they stayed healthy longer, and they lived slightly longer. And so it didn't move the needle nearly as much on lifespan, but a lot on health span. And then those have, like I mentioned, that D and Q combo has been studied a lot in animals. And so really what they're looking at instead of counting cells, they're looking, can we reverse some of the characteristics of aging, whether that's in our brain, whether it's ovarian aging or muscle tissue or heart or metabolic health, you name it.
Are there any studies done on humans and senolytics?
So there's a few pilot studies that Mayo Clinic has published that have used D and Q, and there's I think about a dozen to 15 that are ongoing. That there's a database called clinicaltrials.gov that lists all registered trials, and there's quite a few that are in progress.
Oh,
And
okay.
then there's another compound that Mayo eventually identified called fisetin, or sometimes I've heard it fisetin. That's another polyphenol that there's about 9 or 10 studies on that one that are ongoing in humans.
Oh,
So
good. Yeah, really, like you said, it's in its infancy, right? I'm excited to see what happens because, well, because the animal research is proven. So now we move on to humans, and I think that's pretty cool. And so if people are, mice are seeing more glossy hair and living longer, I'm wondering if technically, I would wonder if it works with brain health or joint pain or other things that women are definitely going through. Maybe their skin will appear better. And again, you could go take it to the next level. I don't know, hot flashes or sleep, fatigue. Does it have any effect on this? And maybe just with your experience with Qualia, you're getting some feedback because it's not an official study, but you probably have a lot of people taking this now and have some feedback.
yeah, so we have a product, Qualia Senolytic, that has quercetin, fisetin, and 7 other. Many of them are other polyphenols, but just concentrated plant compounds. And before we actually even made and sold the product, we made prototypes and did a small, what science would call it, a pilot study. So no placebo. We knew what they were getting. They knew they were getting something, not a placebo. And we measured joint health. And we used a really common scale that measures things like getting in and out of cars and walking up and down stairs and bending over and pain, the things that when our joints are struggling, we score poorly in those areas. And what we did was we dosed the Qualia Senolytic intermittently. So we had people take it for 2 days, take 12 days off, do another 2 days, and then take 12 days off and a final 2. So over about 5 weeks, they would have taken the Qualia Senolytic for 6 days. And we saw just over a 60% reduction in joint-related symptoms. And so we eventually then did that same thing with a placebo, and we saw the same, like mid 60% improvement over that time with that approach to dosing it. We also used another questionnaire called the SF-36, and that it's just a really general wellness questionnaire. So it asks about energy and emotion and physical function, like big categories of things. So it's used in research a lot for just like a sense of general health would be the best way to think of it. And the areas consistently we've seen big changes in people's reporting in the energy bucket of questions and in the emotional well-being bucket of questions. So we've seen that both in our non-placebo and placebo-controlled study. So that would
Okay,
be the
okay.
study. Yeah.
So when you said there's a placebo, like you repeated this with a placebo group, not just,
Correct. Yeah.
placebo group saw 60%.
Yeah, no. So what we would normally do in a progression is a study first without a placebo, and then in the future one that did. So the placebo group invariably will have some improvements in symptoms, right? The placebo can be really strong, but yeah. So what we would have seen is a statistically significant difference between the two, like about a 64% decrease in symptoms in the Qualia Senolytic group and a much lower improvement in the placebo group. And so, which you would see in any medication study, there's some placebo response.
That's pretty amazing to be able to 60%, if you're having joint pain, I think it's pretty significant, feeling better. Was that out just taking it once every 12 days? Like that was a 1 month study or how long?
Yeah, so we did just think of spread out over 5 weekends. On the first weekend, the third weekend, and the fifth weekend, they would have taken the Qualia Senolytic each of the weekend days. And then the 12 days in between, they would have done at least nothing that we asked them to do.
Uh-huh. Oh, wow. Okay. That's pretty fast. I would think it would take,
Yeah.
I don't know, like most supplements, I always say just try it for 3 months. It takes time to kick in some of these things. But that's at least for that study, 60% in with just, oh, well, that's fast. So,
Yeah.
yeah. Do you notice anything with, I mean, do you ever have groups of women in this 50s and 60s who are dealing with, say, hot flashes or other typical menopausal symptoms?
So we haven't done a study focusing on that yet. What we chose joints for one reason. In part, I had mentioned that clinicaltrials.gov. When I was trying to figure out how we would test this, I looked to see what, scientists had decided to try to test. And joint health and using the questionnaire we used was the most common thing I saw. So that seemed like, all right, that's a sound way to approach it. And part of the reason is at one point, scientists thought the cell types most likely to become senescent were immune cells, another cell called endothelial cells. And just think of those, that's the cell type that lines our arteries and vessels that allows them to be nice and flexible. And then fibroblasts. And fibroblasts are the connective tissue cells. So skin, joints would be areas with lots of fibroblasts. So that's why that it made sense to test joints first. What we have heard, and this is in the N of one category, so like the anecdotal category, but as of about 8 months ago, our head of customer service, just at a meeting I happened to be at, that she was at, mentioned that she'd had 6 different women that had thought they were through menopause and then started bleeding again at some point after cycling Qualia Senolytics. So, I mean, maybe just coincidence, but it could also be that there's turning back the time a little bit on the ovarian system.
Oh, that's
So,
amazing. That's amazing. So, but if people haven't caught it onto it yet, the test that you had given them, you said they take two supplements on two for 2 days. No, sorry, they had 2 days where they took the supplements and they had 12 days without. And that's the way, well, Qualia works is right. You take it 2 days of the month and then you wait, and then you just take it once a month, or sorry, 2 days out of the month. So why? Like, how come we don't take this every single day of the month? Like
yeah,
every
so this simple area is going back to that pruning analogy. If you pruned your plant every day, you would actually stop helping it and start hurting it, right? You'd be over pruning. And so going back to that idea I mentioned of voters, in like all you really need to do is at a moment in time, get the cells that are close to voting, should I stay or should I go, towards go to change their mind. And then just repeat over time, right, to manage it. And the goal is it's not like a hormone that we might need to do every day, like a thyroid hormone or insulin, right? That's we're relying on every day to do a specific job. Senescent cells, we're just trying to get these cells that, are resisting going through cell death to change their mind. And we don't have to get them to change their mind over and over every day. We just need to do it once. And so cells that are close, just that punctuated change in nutrition with Qualia Senolytic is the catalyst for that, right? Works a lot on cellular signaling. And then the goal is similar to allergies. So like as a naturopath, the way I would think of allergies is they have to do with a threshold, meaning that if you or I, maybe both of us aren't allergic to pollen, right? So we're like, great, like allergy season, no problem for Dr. Greg. And if for some reason I was exposed to a massive amount of pollen, I would have allergic symptoms. I would have exceeded my threshold. And I mean, with senescent cells, that's the goal. Like we want to keep them below that threshold where they're causing a noticeable problem. So the goal is not necessarily to make them zero in our cells, but it's just to periodically do things to make sure we're below that threshold.
So then wouldn't it make sense if you are somebody in your 40s concerned and you thought, okay, let's just start on some senolytics? Wouldn't it be a different dosage for somebody who's in their 70s because they have more senescent cells?
Yeah, so I think that's a great question. So, and I think, yes, like for a young person, I would say mid 30s, like if 35-year-old Greg, I would probably say just take it once a quarter, but like you don't need to prune very often because you're probably well below that threshold. 62-year-old Greg, I do it once a month, and that's our general recommendation. And in our studies, we did it the equivalent of more like twice a month, right? Because those people were already having an age-related issue that we wanted to, so to speak, put the fire out on.
How old were
And
those people generally?
it ranged from about high 30s up until 70s.
Hmm.
So that joint issues can affect people at a younger age. There's lots of things that can cause that stress. So, but in general, I think directionally that's correct. But I would think of it more rather than putting a number age onto it, really like are we or aren't we struggling with some noticeable age-related issue that if, like, say, something like Qualia Senolytic was making a difference, would we notice that if we did it more aggressively? And if not, then the goal isn't to notice something per se, it's just to be a good gardener periodically. And so that's why, for me, that's the once a month. And if I, for some reason, felt like I needed to do it more, then I would do it twice. But right now, once a month is my routine.
So then for someone, I'm going to have a second hip surgery. So I would think, would I need a little bit bigger of a dosage just because I'm going to be having a major surgery?
So it wouldn't be a bigger amount, but maybe if you're not healing as quickly from that after as you feel like you'd like to, then do it more frequently.
Mm. I see. Okay, so then you're saying just see how it goes and then you can take it. Because it sounds like it's quick acting. If you do have, let's say, joint pain, or if you are healing from something, then you will see it right away. And if you don't get the results, you just up the dose. I mean, do it more frequently. So that's pretty interesting. I think I'm going to have to do that.
Yeah. When the other thing too, I interviewed someone for the Qualia podcast a while back that's a big MD name in the rejuvenation space. So he does stem cells, exosomes, all kinds of really cutting edge things. But one of the things he mentioned is that he'll often do or have people do Qualia Senolytic before stem cells, because stem cells, as an example, after surgery, sometimes some people will do stem cells injections then as a way to heal that trauma quicker, right? Because stem cells are a lot about healing. But if we want our stem cells to rejuvenate things that may be struggling whole body wise, right, then we want to do stem cells away from something that caused a lot of inflammation or get the inflammation under control. Otherwise, the stem cells are going to be dealing with that and not rejuvenating tissue in an aging sense, right? So in a surgery sense, maybe, several weeks before, then doing something senolytic might help because there's going to be some inflammation always from trauma surgery, but we want this surgery threshold or the inflammation threshold to be lower going
Hmm.
into that, if
Yeah.
possible.
So then I'm wondering, is there another way to activate senolytic, I guess, activation other than through a supplement, maybe through exercise or fasting?
So there was a recent study. So in general, probably yes. The most promising thing I think is the fasting mimicking diet, alter longo, and that at least will get rid of some senescent immune cells, whether it does in other systems or not. So that looks like yes. Exercise, exercise is interesting because one of what they would in animals call it anabolic resistance. But what that means is as we get older, our muscle cells are less responsive to anabolic signals, and anabolic would be growth signals. So the same exercise in an older person, older animal, they aren't going to grow as much. They won't synthesize as much muscle tissue. Higher protein, right, is another anabolic signal. And in older animals, when they've done this research, a big reason for that is the accumulation of senescent cells,
Yeah.
right? So that we would have more in our muscles. And then I mentioned like exercise stress, those researchers that commented, oh, it can be like an explosion. So it's a double-edged sword. My sense would be exercise would help prevent cells from becoming senescent. And once to an extent, right? Not if it's like running a marathon every weekend or something ridiculously intense. But once cells are senescent, exercise doesn't appear to remove them.
Hmm. Yeah. Okay. Yeah. I was thinking my head was in the autophagy space. That's why I said exercise. But you just at the beginning of the interview, exercise can activate senescent cells, and that's. But I get it sounds like there's sort of a sweet spot where you can won't clean it up, but maybe you do less if you do a marathon, right, to kiss more senescent cells than if you did some maybe light exercise. Is that correct?
Yeah, yeah. It would be, in my way of thinking, a Goldilocks principle, right? There's some just right amount of exercise that's going to make our cells more resilient. And I don't know if this would help, but stress, I think, is an important way to think about it. Because I mentioned like senescent cells really can be thought of as a type of stress cell that can't be repaired. So when cells get stressed, there's really only a few doors they can walk through. So door number one is, they're resilient. They've got the stress is manageable. So they make more antioxidants. They do whatever they need to basically like, I got this, and walk through that door. Like, and maybe even they got tougher, fitter because of that low amount of stress. But if stress is more than that, then they'll probably take on some damage. And cellular damage may be mitochondrial dysfunction. It may be proteins inside cells getting kind of junked up together. And maybe some DNA got damaged. Something inside the cell got stressed. And so that's door number two. And autophagy then is the solution, or one of the solutions in door number two, right? It takes some of those gunked up proteins and recycles them. And so, and we want cells to go through door number one or door number two, right? Like either I got this or I took some damage, but I can figure it out and repair it. But a senescent cell goes through a door number three where the stress was so much it caused it to be unrepairable, right? So
Okay.
like autophagy would then keep a senescent cell hanging out, right? Like it would be fixing the senescent cell, if that makes sense, right? So,
Yeah.
and autophagy would happen in a lot of places. So autophagy is something that's an anti-senescence thing for healthy cells, but once a cell's senescent, autophagy is not gonna do anything for that particular cell, right? Like the cell's already lingering, autophagy just helps it still linger.
Oh, interesting. Yeah, because we kind of, so I assume that, well, yeah, if you activate autophagy, whether through a supplement or exercise or fasting, whatever it is, well, then you're going to kind of clean up most of them or all of them and you recycle them all and you imagine yourself. But you're saying is actually there are some that are irreparable and then they become these zombie cells or senescent cells and they got to find a different door to go out. And that's got to kill them, just get them out.
Yeah. Yeah, because door number four would be the stress was so big they went right through the cell death door, right? And that's a better door. It's not, we don't want massive amounts of cells going through that at any one time, but that would have been a better door for some of the stress cells to go through rather than door number three.
Is there any advantage to having some senescent cells hanging around?
Yeah, so in a young person for sure, like if like the positive roles of senescent cells, like during pregnancy, as an example, there's waves of senescent cells that actually shape the embryological development of the infant. So they come in waves and then recede. And I mentioned in a young person or young animal, right? Intense exercise, you'll then have a wave of senescent cells that will act to call in the immune system and other reinforcements to help healing, but then the wave recedes. The issue with aging, and it's why I use that distinction of transient versus lingering, is that it's not a wave that comes in and recedes. It's a wave that keeps coming in and eventually floods all the coastline. It just keeps accumulating more and more. So in that sense, there doesn't look to be advantages of having these lingering ones build up and build up over time.
Yeah. So then I'm wondering, so with a fasting mimicking type diet, and if people don't know what that is, it's a diet, it's a very low calorie, and Dr. Longo is brilliant. So he was my professor actually in gerontology. And so he's all about mimicking the fast because you can't there are people who just will refuse to fast, but give them a little food, they may be able to stick to it longer. And it's a 5-day, usually it's a 5-day fast, more or less, very low calorie, certain types of foods, macronutrients. But and he's really big into autophagy. He always talks about autophagy, but you're saying that it may also active some of killing off the senescent cells. But how does that compare to taking a supplement?
Yeah, I don't know. No, I'm not aware of anyone that's made that comparison. And the only thing I've seen him report on is senescent immune cells. So he may have looked at others, but those he has looked at as a marker, right? So autophagy gets mentioned. I see autophagy and senescence mixed up a lot, but think of autophagy as something that goes on inside cells, and senescence is a whole cell at a whole cell level. And the way I've heard him describe it at one point, and this goes back several years, was the fasting mimicking diet. It's almost like it takes the shields down on stressed cells. And stressed cells could also be cancerous cells in his research. And that then makes them more susceptible to something that should then drive them through cellular death, right? So I think that's what his approach seems to be doing. And I wouldn't be surprised if that helps with many different cell types, because in at least some of his research, He's studied diabetes and autoimmunity and quite a few things that at least senescent immune cells and senescent cells are known currently to contribute to. So that would be the only one I know. And I think one of the magic of his is it's that intermittent, right? It's just a brief period, and then the refeeding. A lot of positive happens in that refeeding part, right? So again, I think as science does more, we're going to learn more cool things that happens when we do things intermittently, because it's the doing and the recovering from doing often that matter.
Do we have, or do we know where senescent cells are hanging around more in the body? I mean, in some of these tests, you see that there's some more in the brain and some that may be only in your leg. Or when we talk about senescent cells, it's a whole body thing and it's quite evenly distributed. Give us a visual. Where are senescent cells?
So they would accumulate in all tissues, but unevenly. And my sense would be we all have our Achilles heels, right? Things that for some reason, genetics, past trauma, some other reason, that system, tissue, body part just struggles more. So in that individual, there's likely more there in an uneven sense than in some of the tissues that are doing well. But really all tissues, it used to be thought that neurons, so just stepping back, if you Googled it, you'd see something like cells live for an average of 7 years, but that average is misleading. So some cells, like liver cells, live 1 to 3 years. They turn over pretty quickly. Heart cells, I think it's 4 decades. I want to say muscle tissue, it's like 15 years. And then neurons in our brain we don't ever make new, well, maybe in some parts of the brain there's neurogenesis, but there's questions about that. But it's generally thought that neurons are meant to last a lifetime. So it used to be thought that the only cells that could become senescent were cells that could make new ones, right? So that neurons could never become senescent, but now it looks like they can be. But what really in the brain becomes senescent is the supporting cells, like the immune cells in the brain and the other things like that. So I don't want to overcomplicate it, but anywhere in the body where inflammation is a bit out of control, in all likelihood, at least in that part of the body, senescent cells are beyond the threshold where it's good for that tissue.
Mm-hmm. If we know that, say, fasting would affect a woman's hormones, which it would in one way, or a lot of different hormonal pathways, do senolytics as a supplement, does that also affect a woman's hormones?
So that's not been measured that I know of at all. I have not seen anything on hormone effects in any of the studies on senolytics to date, but it would be a great area to look at.
It would be a great, because you mentioned that there was there was somebody in your team in Qualia who said that perhaps, we don't know if it's a coincidence or not, that it could be activating ovarian rejuvenation or bringing back a period. It has to be researched, but if it were, then that is pretty amazing. I mean, that's something worth looking at.
Yeah, so what has been looked at, so adipose tissue gets looked at a lot, fat tissue, right? Because of its connections to metabolic health, like your insulin resistance and blood sugar and lipids and all things like that. And in the animal studies, at least, senescent cells don't per se make the animals fat directly, like they don't cause more fat cells or bigger fat cells, but they change the metabolic signals that the animals make. So, lipids, triglycerides, blood sugar, insulin, right? So insulin will be the hormone I've seen most studied. But my guess would be just because in these animals, there's some rejuvenation occurring whole body wise, that would be hard to happen without impacting hormones as well.
Is there a certain profile, a certain type of person who should definitely be on senolytics and others who probably should stay away from it?
The only thing I would say would be more like who should do it more or less aggressively, not who should or shouldn't do it. And so, again, I think of it like almost in a financial investing sense, right? Like what would be the right type of investment strategy for someone at age 20 might be different for someone at age 50. And so the way I generally think of it is how I mentioned, like, oh, for a younger person that wants to prune away senescent cells, quarterly might be, more than adequate. For someone now that's getting into their 40s and 50s that wants to start doing it preventively once a month seems like a much sounder investment strategy. And then for someone that's already struggling with issues, or you mentioned someone maybe in their 70s that would be expected to have a lot more, then at least maybe initially let's do it twice a month to see if it makes a big impact that's noticeable.
Mhm.
And then we've touched on this a few times. It's 2 days a month, so it's not a big time investment. It is 6 capsules a day to do the entire recommended amount on those days. But those days that I do it, I just don't take other supplements. I just do the Qualia Senolytic, and I always do it my first weekend of the month to just make it an easy thing to remember.
Exactly. That's pretty much the biggest thing going for me, and that Qualia is just twice a month, and that is so easy. Considering I'm a supplement queen, so I'm taking all kinds of supplements. So 6 supplements doesn't make a big difference. But yeah, for somebody who's not used to that, yeah, just stop everything else, or you taking it, doing that twice a month is nothing compared to the benefits that you're getting. So I strongly recommend everybody just give it a go, honestly, because it sounds like it's possible to get quick results, to feel something, especially if you're actually going through something. And what are you seeing in general? What kind of feedback are you getting? Is it generally quite fast acting, or across the board takes a little bit longer?
So I think it just varies person to person, but in I work more directly with the people in our studies and less directly with like customers, right? Just the nature of my role is I only get questions when someone's confused at customer service. I don't necessarily hear all the good things that come in, but I know energy is a common thing we hear, and we've seen in our studies energy levels people report subjectively, mood category things like handling stress, feeling anxious, things like that, and how those impact our day, I see commonly. And then obviously things that fall into that, like pain, inflammation bucket, which a lot of things with age fall into that
Yeah.
bucket, right? Like our tendons, right? Like rotator cuff. I was just reading about rotator cuff surgery for another project I'm working on related to stem cells. And a lot of that is the tendon stem cells just aren't replicating like they should in a young person, right? So like our tendons don't have the resiliency as we get older, and lots of things, right? So I know for me with Qualia Senolytic, a thing I looked at initially, and in part just because of that anabolic resistant, right? The muscle thing was like, oh, well, taking this maybe unstick me from where I've been seemingly plateaued with my weight training. And it did for me. It seemed like maybe it was all mental, but that really quickly, all of a sudden, I had some new personal bests without feeling like my joints were inflamed.
That's a big one, especially if you're active like us. So then let's talk about the Qualia Senolytic itself, because you helped formulate this. You mentioned that there's quercetin in there, right? And fisetin both, right?
Yeah. Yeah. So, and Fisetin, so the kind of the trajectory after the Mayo researchers identified quercetin and dasatinib, then they decided, okay, quercetin's a polyphenol, maybe other polyphenols would also be senolytics. So they screened, I don't remember if it was 8 or 10, but of that group, Fisetin was the strongest senolytic, and it was even stronger than quercetin, and it was more versatile than quercetin in that study, so they could give it on its own. And the studies where I mentioned where Fisetin is being studied in humans, they give it at 20 milligrams per kilogram body weight. So a lot. It's a big amount of it. So you'll see in Qualia Senolytic a lot of Fisetin because you want to give enough to be meaningful.
So then why do you have quercetin if it's not
Because there's complementary in a sense, like they inside a cell, they work slightly differently. And so the other thing that led to the stacking of D and Q together is in that very first 2015 study, the Mayo scientists had noticed that quercetin was a senolytic in endothelial senescent cells, but not in adipose cells, not in fat cells, where dasatinib, it was the flip-flop. It was senolytic where quercetin wasn't. So something can be senolytic, but that doesn't mean that it's going to work equally in all of our tissues. So that's one of the reasons we stack these different things together, because Fisetin did work in adipose tissues. Quercetin worked in endothelial tissues. Something like Piperlongamine, which is it's from an Ayurvedic plant called Piperlongamine. Piperlongum is senolytic, and the use of that plant in Ayurveda has to do with lungs and kidneys. So that hasn't been studied yet in a senolytic sense, but because of the traditional use, it's like, okay, maybe Piperlongamine is more attracted to those tissues. So we stack 9 different things together, in part because they're senolytic, but some of these compounds, just in a natural medicine sense or naturopathic or herbalist sense, clearly seem to work more in some tissues rather than others. And going back to that original research, we know that things can be senolytic, but that doesn't mean they're equally senolytic in all tissues on their own.
Okay. So yeah, in addition, you've got some curcumin and olive leaf extract. So something called luteolin. I'm not sure what that is, but you've got these interesting other herbs, I guess, or components, milk thistle, and that I guess are contributing in it, but is it quite general? Because you can say fisetin, okay, that's the most active ingredient. Why would is there a reason you're putting all the other things in there?
Yeah, so in that original, say, group of 8 to 10 polyphenols, 2 others they identified, they being the Mayo scientists, were luteolin and curcumin.
Mhm.
And so those are also ones that are being continue to be investigated as senolytics.
Oh,
And
okay.
curcumin, brain joints would be some of its affinities. Luteolin definitely as a brain. And then mechanistically within inside cells, these things just work slightly differently to get the voters to change their mind. And at Qualia, one of the things we tend to take a systems approach, like we would look at multiple pathways, and is there a way to positively influence more than one? Because plant compounds, like dasatinib, really powerful medication, right? The D part of the D and Q, but with that comes, as you alluded to, more risk as well. With these natural compounds, the risk isn't nearly as high, but they're not as strong either, right? So stacking ones up that are complementary to us makes a lot more sense.
Mhm. So curcumin, yeah, we all know this is an anti-inflammatory. I didn't realize it was being researched as a senolytic. So it's quite
Okay.
powerful in so many ways. That's amazing. So, okay, I'm a fan. I definitely love the concept, and I've been taking Qualia, and I'm excited to. I want to actually take a little bit more when I'm going through the surgery, and I'd see because I did one hip already. Let's see if I can get the other hip a little faster. So
Nice.
that would be really interesting. My own little N of 1 study. I'll keep everyone posted. But I appreciate so much everything. So informative. I never knew so much about senescent cells, and I just kind of thought, oh, okay, zombie cells. And I would love to see more research done on menopausal women and senescent cells in general, and then how senolytics can help a woman through that transition. What do you think is the most important thing that a woman in this menopause transition should just know about senolytics or senescent cells?
So I think the most important thing is when you think of what are senescent cells doing, if they're accumulated enough to cause a problem, is inflammation, right? Like things under that bucket. And so as you're going through menopause, the things you're experiencing that would be known to be either directly worsened or maybe caused outright by inflammation, think, okay, well, my zombie cells may be contributing to this, and maybe it's worth me doing a better job of being a gardener to see if it makes an improvement. And then if you do something like Qualia Senolytic for a couple of dosing cycles, then just pay attention to those particular things to see if they're becoming better.
Yeah, actually, inflammation is the big one, I think, for everyone, men and women, menopause or no menopause. Like, and as we age, we know it's a big one. I would love for everyone to give it a shot. Go to qualialife.com/hack my age. I'll have a link to that in the show notes. You're going to get 15% off, and you're going to have that code hack my age. You can learn so much more about Gregory at qualialife.com. You've got the Facebook page, the Instagram, the LinkedIn. I'll have links to all of those social media contacts in the show notes. And is there anything else that we should cover that you'd like us to know about, or things coming up for the future of Qualia?
We will, in early April, be launching a joint health product, which I think pairs really well with doing the rest of the month or most of the rest of the month when, away from the 2 days when you're doing, because our joints just need a lot of love, right? They struggle. And that one also did really well in our pilot study. And then otherwise, I would say, no, I just really want to thank your listeners for bearing with me in what's a pretty cutting edge area right now.
Yeah, no, this is something definitely actually, before I let you go, I have one last question because I started using a senolytic skincare. It's something I put on my face, and it's supposedly sort of stops the accumulation. It doesn't kill the senescent cells, but it stops them from accumulating. Is that even possible? Do you know about?
Yeah, so within like they would use the category therapeutics. So think of that as the umbrella. One of the things under that umbrella are senolytics, things to help eliminate cells that are already senescent. Another is called xenomorphics, and that would be things that help suppress the inflammation. So you didn't get rid of the senescent cells, but you're at least mitigating some of the inflammation it's causing elsewhere. And then another would be thought of as xenoblockers. So those are things that would help our cells become more resilient. So they're going to go through door number 1 or 2 instead of door number 3. So NAD would be like things to boost NAD naturally would be in that blocker. And I know niacinamide topically, as an example, can really be good for skin. So the short answer is like, yeah, scientifically, I don't know what that product is, but their story is scientifically valid. So.
Oh, good. Yay. Because I see difference. And I was like, I hope it's not just marketing, but it seems to be a difference. So that's really good. So I'm going to be sharing my experience through Qualia as I go along. I would love next time that we talk about the brain because Qualia Mind, I've been using that one and I feel way more focused. I absolutely love it. I have to say that is our next conversation, if you're okay with that.
Oh, I love talking about the brain. So yeah, I would enjoy that.